Our objective for today, I can add and subtract polynomials. Read together. 1, 2, 3.
I can add and subtract polynomials.
Alright, so we're still on the same concept, which is polynomials. We already know what they are. So in your FAIR model, I want you to start your FAIR model by yourself without looking at your notes. Write a definition, an example, non-example, and a hashtag. I'll give you 2 minutes. Okay? Go. Alright, let's see if yours looks something like this. Yes? Definition, monomial, or sum or difference of monomials. And guess what? That's one of the questions on the part K. I don't know if you saw the last one, number 22. Yes? Alright? Finish that on your own at home. Copy the steps underneath the FAIR model. Step number 1, distribute, multiply factors to each term inside the parentheses. Step 2, identify like terms. Step 3, use commutative and associative properties to combine like terms, add and subtract. And at the end, simplify. Why do we simplify at the end? Because we're still in expressions. We haven't moved on. Copy that, please. Alright, so we got this, yes? Alright, so before I get started with the approach now for addition and subtraction polynomials, I don't know if you guys noticed, like from the way you were presented mathematics before, have you guys noticed that I presented just a little bit different? Because I need you guys to understand it in a different approach. So today I'm going to approach it again in a different way. But before I do so, you can understand the way I think. Remember the first assignment, the very first day of the school year, I said, go home tonight and watch the video on intro to the additive inverse property. Remember that? And what was I doing? I was planting a rosemary bush right there in front of my home. And remember that one? So, and that is pretty much my brain. That's how it works. Everywhere I go, I see math everywhere. In my sleep, sometimes in my sleep, my wife wakes me up with an elbow because I try to teach her whatever, and she says that I get upset because she doesn't answer the question correctly. Sometimes we were watching movies. Sometimes in the movie I see math all over the place, and I say something. My wife's like, just watch the movie, stuff like that. But let me tell you why, because part of me cannot stop my brain from doing that. So let me just give you a little bit insight as to what I see that's around us that you guys never really knew, that math is everywhere. For example, have you guys noticed, like if I was to ask you, go home and open your pantry, get a cereal box out. What figure is a cereal box? Rectangle. If I ask you, go into your game, what figure is the box of the game? Rectangle. If I ask you to get your ID out, what figure is the ID? Rectangle. Also, if I said, where is it at? I had it here. If I said, I'm going to get a gift card out. What figure is it? Rectangle. Have you guys noticed that it's the exact same size as your ID? Pretty much, yeah. No. No, what? Here's my ID. So what? Now, that is not like mind-blowing. Let me show you what mind-blowing is. Ready? Here we go. What if I said, go home and measure the box of cereal, the long side by the short side, and divide the long side by the short side of your cereal box. You came back on Monday, we added all the numbers and divided them by how many people are in here. You know what number it would give me approximately? It would give me a number of 1.618. Let me finish. What if I said to measure the long side of the box of your game divided by the short side of the box of your game? Guess what number is going to give me? 1.618. Let me finish. What if I ask you to get your student ID out and ask you to measure the long side divided by the short side? Guess what number that's going to give me?
1.18.
Wait, I'm not done. Here goes the best part. Ready? Let's say I ask you to measure your height and divide it by the distance of your belly button to the top of your head. Guess what number it's going to give me?
1.18.
If you measure the height and then the length of the wall, what do you know?
Very good question. It would give me something very close. Let me tell you why it makes sense. Watch. If I was to ask you to measure the length of your TV by the width of the TV, guess what it's going to give me?
1.18.
And guess what? Since we have numbers and numbers embedded in us, and I can continue. Let me continue. If I ask you to measure from your shoulder to the tip of your finger, divided by the distance of your elbow to the tip of your finger, guess what number it's going to give you? Yeah, that was a little bit off, but most of them will. Anyways, that's how I see things. You can see math all over the place. And I'll explain it later. But let me just get into the lesson now. Now, I saw something the other day. I saw the empty lot over there by where they sell the raspados. Have you seen the raspalandia place? And I was thinking like, man, it would be a nice place to put a store. Well, I said I imagine. So I went ahead and did a little sketch. Here's my store. If I was to put a store there. There it is. So, Mr. Q's Pet Shop, I would say that it's on 23rd Street. Bam! Look at the phone number. Mr. Q's Pet. Bam! Let's go. So imagine I had a store, and I was going to specialize this on certain pets. So the pets that I would specialize in were dogs. Aww. These are Siberian Huskies. Cats. Aww. Dolphins. Aww. And money. Somebody asked her, like, Mr. Q, how are we going to have a dolphin? I'm all, well, do you have a pool? No, then you won't have a dolphin. Anyway. I know, right? Okay, look up. So, that's what we're going to specialize at the store. And I said, okay, I'm going to make, instead of me working the store, you guys are going to be my employees, but I'm going to make two of you my managers. So I'm going to say Jessica, the manager, and you want to be manager? No, not you. No, that's fine. Cooper, the manager. Cooper. Hold on. So we got two managers, and I say. So, let me continue. So, I'm going to leave town, and I tell the managers, I said, okay, Jessica, Cooper, I'm going to be leaving. I'm going to call you, so like that you guys can take inventory. I'm going to send you for the store. So, they're like, all right. So, I go out of town, and I call them. And then, Mr. Keith, catch up. I'm up. Cooper? Oh, no, it's Jessica. Oh, hi, Jessica. So I said, Jessica, let me give you the inventory of what's coming in on the first truckload that I'm sending over to the store. Ready? Yes, Jessica. All right, so I said, we're getting in 7 Siberian Husky dogs. You know, oh, so she starts writing all that down. I'm like, but instead of using all those words, let's use symbols for each pet. So from now on, whenever I talk about dogs, we're going to use the symbol X. For cats, we're going to use the symbol Y. For dolphins, we're going to use the symbol X squared. And for money, just write down the number of the money that's coming in the envelope. Okay, it's the correct receipt. So then she says, okay, I'm on. Okay, so you ready for the first shipment? Yo. Yes, excuse. All right, write this down. We're getting in 7 dogs. So I'm going to write what? 7x. Plus, we're getting in 5 cats. 5y. We're getting in 4 dolphins. 4x squared. And I'm going to send you an envelope, $2,323. So far so good. And I said, so go ahead and hang up. And right now the truck should be right in front of the store. I believe they just called me that got there. Get everybody else to work and have Justin pick up the poop from the. Oh, okay. All right. So then I said, I'm going to call you later on for the next shipment. So then I call later on. Mr. Q's Pet Shop. Oh, Cooper. All right. Cooper, write this down. You know the symbols, right? Yes. We're getting 3 more dogs. So what is he going to write? I said 4 cats. 2 dolphins. And I'm going to send you $60 in an envelope. So he's going to write 60. Right? All right. So with that said, focus please, focus. With that said, now we should be able to come up with a total of what's in the store. Yes? Without writing it down, look at it. Tell your neighbor the total of each type of pet that we're going to have at the store and the total amount of money. Go. Selena, go. Tell us what we have. Go. 10 dogs plus 9 cats plus 6 dolphins plus. Okay, hands if you agree with that so far? Okay. So basically what we just did, we combined like terms. We used 2 different polynomials. By the way, these are polynomials. Does everybody agree with that? And we combine like terms. That's what we do for number 15 and 16 on your study guide. Was that pretty simple? Now check this out. Before, just to clarify, look up before you do anything else. Why didn't I combine that one with that one? Talk it over the neighbor. Why didn't I combine that one and that one? All right, who can elaborate on that? Ethan. It's not on the square root? This one has a squared and the other one doesn't. So what are we saying? That the only time we combine is when the variable has the exact same exponent. Does that make sense? They might have the same variable, but does it have the same exponent? No, that's why we didn't combine it. Jesse? No, hold on. Give me a second. All right, so look up, please. So, this is what I have. 10 dogs, 9 cats, 6 dolphins, and I have $2,383 in the store. However, we're going to have a blowout sale this weekend. Pay attention. So, leaving the store, we sold that weekend 7 dogs. We sold 5 cats. We sold 3 dolphins. Okay? And I have an extra $1,000 in the cash reserve. So look up, please. If we sold this, who can give me the total number of dogs that we have left? Marco. I'm sorry? 3x. How many total cats? Pedro. 4y. How many total dolphins? Yoel. 3 dolphins, 3x squared. Alright, that's correct. Does everybody agree with that? Okay, so now check this out. Here's a dilemma though. This is positive 10 and this is positive 7. How did we get 3? Don't say it out loud. This is positive 9y, this is positive 5y, but we ended up with 4y. This is positive 6x squared, this is positive 3x squared, we ended up with 3x squared. Talk it with your neighbor, let them know how we got to that point. Yes. Let's see, Alexa, how do we get to there? Because we subtracted. However, does everybody see this? That this is a positive. If we subtract 10 from 7, then the 7 has to be a what? Negative. So, look at this. If this is a negative 1 and a visible 1 here, when we distribute, this becomes what? Negative. This becomes negative 5. This becomes... Therefore, with that said, how much money do I have in the store? Tell your neighbor, please. Helena. 3,383. Hands if you agree with that. And that is correct, because when we distribute this, this becomes a what? Positive. Everybody got it?
Yes.
All right. Now, that was easy. Are we there? Okay, the only thing I want to do today, aside from that, is introduce now using geometry. So to get the last person on each row, go get a baggie of tiles that are in the back and give one to each in your row, please. Hurry up, please. Now, as you bring them forward, this is what you're going to have in your bag. You're going to have a yellow tile that we're going to label as 1. Focus, please. However, when you turn it over, if it's red, we're going to label that one negative 1. Are we there so far?
No.
Next, if I show you this, this is known as X. But if I tell you to get a red one out, this will be a what? Negative X. If I tell you to get this blue one out, this is known as X squared. But if I ask you to do a red one, then it's a what? Negative X squared. Here goes again in case you missed it. Once again, the yellow one is 1, this one is negative 1. This is X, this is negative X, this is X squared, this is negative X squared. Everybody there so far?
Yes.
Alright. Does everybody see those? Okay. I'm going to clear my mat. And this is what I want you to do. I want you to put in front of you the following. Look up. I want you to put X squared plus 3X plus 2. Show me that with tiles, please. Put those in front of you. X squared plus 3X plus 2. Hurry up, hurry up, hurry up. X squared plus 3X plus 2. Let's see. Let's see. Does everybody have this? Let me tell you. Look up. Does everybody have an X squared, 3X, and plus 2? Hands if you got that. Okay? Next, this is what I want you to do. Leave that there, and underneath I'm going to give you another polynomial to bring. Ready? There you go. The other polynomial is, look up, I want you to show me negative 2x squared plus 1x plus negative 3. Put that underneath the other one that you just did. Negative 2x squared plus x plus negative 3. Let's see if you have what I have. Look up to the screen. negative 2x squared plus x plus negative 3. Are we there so far? Okay, so watch. This was the first one that we did. This is the second one. Look up, please. Does everybody see any zero pairs? Does everybody see them? This one with this one, that's a zero pair. What else? Two of these with two of those. And what do we have left? One of these, four of these, and one of these. And that's how we combine like terms using geometry. Now let me show you with symbols how that looks like. Look up. Look. X squared plus negative 2x squared. Oh wait. Okay? Okay. Ready, Justin? We're all waiting for you. Okay. Next. 3x plus x plus 2 plus negative 3. What property allows us to do that? Tell your neighbors, please. Ariana, what property? Commutative property of? Are we multiplying? Of addition. Next. Look what I'm going to do to combine. Guys, I could have finished a long time ago. Ready? What do I have left here? Negative x squared. What do I have here? 4x. And what do I have here? Negative 1. What property allowed me to do that? Associative property of addition. And that's how you combine using properties and symbols. Okay? So for this weekend, home play, study guide. Now you can do it today, tomorrow, and Sunday, 3 days in a row. Woo! Hello! Make it a math family night. Pack up your tiles, throw them in the, don't throw them, put them in the little bucket in the back. Have a good one, guys. If you're at home play, see you guys tomorrow. Bye. I mean, till Monday. Bye.